Rubix provides set of plugins to build powerful business applications on top of Eclipse-rich client and remote application platforms using low-code app development. Unlike other low-code app development frameworks, which requires learning of multiple scripting and various third-party tools integration, Rubix is completely meta-objects driven and extensible framework, which only requires Java language constructs to develop and deploy applications. We're going to construct data editor using Rubix framework, step by step. In this demo, we build customer data editor from scratch. With Rubix low-code approach, developers can assemble and build data applications in record time. Import Entity Wizard imports existing RDBMS table schema and generates entity object which includes structural elements of the underlying table columns, corresponding UI elements, configurations, relations, and runtime constructs. The generated entity model can be further customized by developers to implement features, functions, validations, and business rules. Let us start by importing entity. First we need to select the connection profile to list available table schemas. Select customer schema from the list. Select package to generate the Java source artifacts. By default, the Rubix wizard populates control bindings for each column, inspecting the data types represented in underlying schema. The user can override the default data bindings generated by framework and provide custom control selection for each column. Entity is required to provide lookup configurations for each relation column. Lookup columns represent foreign references in entity. For each lookup column, we need to provide parent data provider, join column, and default display column settings. For account receivable, select chart of accounts as parent, row ID column as primary key and account number as display. List type entity column requires value entries to populate drop-down list at runtime. The list value is also used to evaluate conditions and invoke various business logic operations in data models. We select pay method column to provide list of values. You can add list value individually or provide comma-separated values which are processed and segmented automatically for value parts. Select default display column for this entity. Select columns to automatically generate code subs for column data change events, where developer is required to provide specific implementation. Alternatively, you can achieve the same by providing method annotations in the generated model at any time. Let's inspect the generated entity class. The generator has created column name and respective camel case labels for each column in the entity model. Initialize columns method is the place where developer adds simple entity column types to the model. This includes text, numeric, date, time and list of values types columns. The generator extracts underlying table schema constraint rules while populating the content here, for example the length of the column and required attributes, etc. Initialize lookup columns method is the place where developer adds lookup columns. The wizard generates column relations based on the lookup configurations provided. The wizard generates method called initialize transitory columns to add transitory type columns to the model. Transitory columns underlying data is not persisted during record operations, hence can be used for calculated type columns, where value is derived from expression. There are other types of entity columns, represents data charts, maps and actions, which we will cover later in this demo. By default the generator creates collection of search filters and results. These collections are used as a template references, while providing search operations on editors and lookups. The developer can add remove columns from generated lists. When composing forms using entity references based on this model, the default search content is extracted as a copy. However, this list is only used as a reference. Once extracted by Form Designer, it can be overwritten in terms of index and visibility. Wizard automatically generates a method called doSaveRecord, which captures and performs validations and various operations on attached record before committing changes to the underlying table. The generated method contains entry to validate required column values. Similarly, there's another entry generated to validate primary key violations during insert and update type operations. The developer can add more business rules here by simply introducing content validations, etc. Rubix provides wizard mechanism to generate data editor artifacts by defining entities with their respective data relations. These data entities and their relations are used to populate and render widgets during design phase of the editor form visually. Generated Java editor class can be manually modified to add remove additional data entities and relations, at any stage of the development. Let's create Rubix editor by composing entity objects. Provide Java class name and editor title. Select package to generate the Rubix editor. Rubix editor requires primary data set, in order to capture and broadcast data to registered participants. Subsequently, developer can add secondary datasets by providing valid join conditions for each. Select customer as the parent dataset and row ID as the primary key. Select customer contact lines as the new dataset and R_ID customer as the join column. Similarly, developer can add multiple datasets to the editor by providing valid join column configurations. Based on join conditions, the framework automatically generates one-to-one and one-to-many type data relations between datasets. You can add multiple datasets at any time and refresh the editor designer to synchronize the palette data contents. Let us inspect the generated editor and editor input classes by Rubix framework. The generated editor class contains editor configuration variables, required by Rubix framework for various internal mappings. The wizard generates editor input class, which provides datasets and their respective join configurations. ID customer is the primary dataset for this editor content. Subsequently, address lines, contact lines, and credit review lines are secondary datasets joined by many-to-one relation with primary dataset, which is customer. Rubix provides rich user interface designer to organize data editor content visually using drag and drop. The designer automatically populates widgets from the underlying data entities registered during the editor wizard. Developers can add remove data entities from the editor at any time, during the design stage. Layouts can be further customized to produce enhanced user interface experience. Double-click Customer Editor to start designing the content. Drag and drop the primary dataset, which is customer on editor. We're going to use template E as the base layout template for this editor. Drag and drop layout template E on the editor. Let's add widget container on first compartment. Insert group heading and change the default caption via property sheet. Rubix Designer allows to modify generate default properties of the editor model via property sheets. From Data Observers palette, drag and drop data entity columns represented as data widgets. For each entity column, corresponding data widget is populated in the Observers palette with respective data type. Only one instance of the observer widget can be placed in the editor. Upon adding and removing widgets, the editor automatically refresh the palette with updated widgets content. Insert tab folder and add multiple tab pages to place one-to-many detail observers. Tab folders are not limited to accommodate one-to-many data views alone, it can accommodate any type of container including widgets, charts, maps and layouts. Insert detail table container to place one-to-many observer, which is a table view. Select Detail Observers palette and drag and drop Customer Address Lines Detail Observer. Now that we have table views for each one-to-many detail observers in place, let us add detail observer columns to design table view contents. Add widget container to place widgets. For each table view, drag and drop one-to-many detail table widgets by selecting the respective entity from the Detail Observers drop-down list available on palette. Let us open the entity class to introduce new column manually. For this example, we will show you how to add new chart type column which is transitory in nature. The transitory columns are calculated and display their contents on the fly. As a thumb of rule, we must define unique column name and caption for the new column. These attributes are used reflectively by form designers and other entities when referenced in multiple places. Let us jump to initialize charts method source block to add new chart type column. You can place your chart implementation by adding the new chart column to column factory. Now that we already have the chart column registered, we need to provide mechanism to populate its contents. This can be achieved using Rubix annotations. On change of customer ID column data value, we set monthly sales chart with arbitrary figures for each customer. Ideally in real world, these figures could be generated from a query for given customer. After successfully adding new chart column to underlying entity model, the editor designer will alert the user, refresh contents to synchronize the new model changes. Let us add chart container inside right panel to place the new chart. Now you can drag and drop the monthly sales bar chart from the Rubix Charts palette. Rubix Designer allows the user to preview the editor form visually with live data by providing a valid connection profile. WYSIWYG Preview can also be used to test validations and business rules implementations of the underlying entity model, without having to deploy, run the client application. This will greatly promotes the rapid application development, by reducing number of deploy, run, and test cycles which consumes considerable time for each iteration. Let us test the functionality of the editor by invoking Find Records action. User can navigate the record collection by page. The records can be searched by providing set of valid filter columns. For each column filter, Rubix will list down applicable operators and cell editors for underlying data types. You can combine filters to optimize search criteria and locate the records easily for search context. Rubix Editor provides two types of data views, called Table View and Record View. Record View is used for CRUD operations exposed by underlying data provider, whereas Table View returns collection of records per view for easy navigation. We will quickly show you some of the operations exposed as actions for demonstration purpose. New record action clears the record buffer and prepares input widgets for data entry. You can notice that the required columns are decorated with icons from the underlying column constraint rules. The list of values type columns are populated with entries defined during the entity creation. These values can be customized by adding or removing content from the entity column configuration anytime. During the save record operation, Rubix triggers record data validations defined in the underlying entity model prior to saving the physical record. The editor provides visual feedback with errors and warnings when validation or business rules are found violated during the transaction. Rubix Designer highlight columns with errors that requires immediate attention with red color. Column decorations associated tooltips includes the warnings and errors context returned by entity during failed transaction. Relation entity columns are decorated with lookup controls. Lookups provide convenient mechanism to filter and select a valid record from the underlying foreign tables. Once all warning and errors are resolved, we can save the record. Now let us modify the record we just created. During modify operation, you can notice that the record toolbar switch the context to modify record operation by enabling the save and cancel actions. Modified columns are highlighted with blue color. This will assist the developer to easily identify the set of modified columns during create and update type record operations. However, if you revert all the modified column values back, manually, the record toolbar switch context to navigation automatically. For each data provider implementation, including one-to-many, the Rubix provides mechanism to perform CRUD operations against the underlying entity model. One-to-many type views automatically manage relations by storing references during record transactions. When records are inserted in detail table, the record stores the reference to master record, which is the selected customer, hence called master detail type implementation. The record view content automatically highlight icon decorations for each required columns during the insert and update type operations. When new validations are introduced on one-to-many type views underlying entity model, they are automatically executed during various CRUD operations performed by referenced views. This will simplify model to promote centralized entity models and inherit features and functions when referenced in multiple editors and views. Rubix provide mechanism to register on cascade delete type implementations for one-to-many type relations. This will result in deleting all child records, referenced by parent during delete operations performed. For example, when selected customer record is being deleted, we force delete child records of address lines, contact lines, and credit review lines. We have covered enough foundation work on Rubix framework by learning concepts of entities, relations, and editors. Let us put this work together and test the behavior at runtime. By default we use the Jetty servlet container shipped by Eclipse wrap for this audience. Alternatively, war configuration can be generated and deployed on supported servlet containers by using Eclipse War Products tooling. We have created different plugins for various application modules to separate concerns. For example, we have ID module to manage identity artifacts and IM module for inventory artifacts. Developer has the complete freedom to move Rubix artifacts around modules without restrictions. However, Rubix promotes plugins for each logical module separately, which will simplify management of the artifacts. Rubix is required to register newly created entity and editor via plugins extensions. Rubix use Eclipse plugin extensions for various features. For each Rubix editor we create using the wizard, we must register the same under org Eclipse UI Editors extension. This is the default behavior of Eclipse, when registering editor part. Similarly, each entity must register with org Rubix Objects Entities extension. We have completed all tasks, in order to test the Rubix editor runtime behavior. We have a small RAP application with a navigation view to demonstrate the power of Rubix generated editor at runtime. The final step is to call the editor when navigation views invoke customer editor action performed. This can be achieved by Rubix dataset editor utils, invoke editor by name action. We're going to run this test application using default shipped Jetty configuration. For each plugin, a bundle is created for deployment. We have two separate views in this application. First one is used for login and the second one is used for application module navigation. All features we demonstrated via preview mode while designing the Rubix editor is available inside this web application. For example, we demonstrate the find record feature of the Rubix editor with content filtering. We have only covered the basic framework features here. Please follow the advanced tutorial for more. Fast forward your business application development using Rubix framework. Thank you for watching this tutorial.